Welcome to Maths and Science by IITian channel. In this lecture, I will be taking up a very important topic in physics, that is work, energy and power, lecture number 5, where we will be discussing about the potential energy. Potential energy U. What is meant by the potential energy? Potential means something has the potential to do something. If we say somebody has the potential, that means he has got some energy stored in him to do something. He has the potential. Similarly, if a body has some potential, if a system has some potential, means some stored energy is there with it. That is called as the potential energy. For example, a compressed spring, it has the potential energy in it. When you release that spring, it expands. That means it restores to its original position. When it is compressed, it has got potential energy. That is spring system. When you take an object from ground level to a top of a hill or a top of some building having a height h, then you are working against the gravity. Gravity always pulls the body towards the center of the earth. And as you move up, that particular stone or object at different heights has a potential energy. Once you release it from your hands, it starts to fall down. That means some stored energy is the potential energy. Similarly, in earth crust, tectonics, initially earth has lot of tectonics taking place. Tectonics means the layers of the earth under the sea, they touch each other and move. And the earth is formed beneath the earth crust. There are volcanoes and they cause an earthquake. They have the potential. When this earth crust has the capacity, or acts as a barrier so that the stored energy beneath its crust is not, it will not break the barrier and come out. But in case of weak faults or fault lines where energy can seep through, this energy will seep through and it makes earthquakes to take place. That means a spring system, earthquake system, and also a stone in hand, taken to the top of a tower, top of a building, may not be very high, maybe some 1 meter, 2 meters, 3 meters. It has a potential to fall down, that particular rock in your hands, if you leave it from your hands. And beneath the earth crust, the movement of because of the tectonics and tectonics movements, there can be, because of volcanoes, if the energy crosses the barrier capacity, then it makes an earthquake to occur. Similarly, in case of a spring, a tight spring, it is the spring. It is stretched spring. It is not stretched, rather it is in original condition. And if the spring is compressed, the spring length here L, here it is L1, it is compressed by some force. Then if L1 is less than L, what happens? The spring is compressed. It will have a stored energy. And when you release these forces, what happens? When you release these forces, it will come back to its original length of L. This is spring system. Similarly, there are many physical systems where we can define the potential energy, the potential of that particular system. Then we already know what is the kinetic energy. Now we will go further how this equation has come. For a unidimensional force Fx, the partial derivative of potential energy with respect to x with a negative value gives the force. This is the very important equation. This equation will be useful not only in mechanics, in quantum mechanics, and also in many theories, modern physics theories. With this introduction, we will move further for understanding the concept of potential energy, kinetic energy from the Newton's law. As I have already explained you in my previous classes, a system, equations of motion are controlled by positional vector that is x and rate of change of positional vector. That is x dot. This you always please remember. If it is O and if it is a positional vector P, This is OP bar. Then with time, what is the change in the positional vector with time? For example, the particle P has moved to Q, that is Q, in a time t. It is moved from P to Q. Then positional vector OP is moved to OQ in a time t. Then rate of change of that positional vector position is also to be studied to know clearly about P and also to know clearly about Q. Hence, if it is one dimensional, then we have to study x and also x bar to understand the equations of motion. What is x bar here? X bar is equal to rate of change of x, that is equal to dx by dt. Then x is known, dx by dt is known, means you can have an understanding of the system and the equations of motion. Now, this is the basis for mechanics. Now, x double dot is equal to d square x by dt square. For example, we will make it further clear. X double dot, one dot means one differentiation more, rate with respect to time, d by dt of x dot, that is equal to d by dt of dx by dt, that is equal to d square x by dt square, which we call it as acceleration. X dot we will call it as first we will call x is equal to displacement, x dot is equal to velocity dx by dt, x double dot is equal to acceleration. Once you know x and x dot, that will be sufficient for defining a system. Now, in case of Newtonian mechanics, for 1 degree of freedom, that means in one direction only motion is there, 1 degree of freedom, then we can say acceleration is a function of x only. That implies acceleration minus function x is equal to 0. Please try to follow it carefully. And what is kinetic energy? We have already seen half mv square. What is v? Half m x dot square. That is kinetic energy. D by dt of, what is a d by dt? Rate of change of kinetic energy. What will be the d by dt of kinetic energy? That is equal to half m into d by dt of x dot square. Do you agree? That is equal to half m into 2 into d by dt of x dot into d by dt of x dot. Do you agree? From the simple differentiation, then d by dt of kinetic energy is equal to m into x dot into x double dot, because d by dt of x dot we have already defined it as d by dt of x dot is equal to x double dot. If m is equal to unity, let us say, then what happens? D by dt of, because m is a constant, a mass, then d by dt of kinetic energy is equal to x dot x double dot. Do you agree? For a unit mass, let me consider. Now, from the principle of conservation of energy, what is the principle of conservation of energy? Principle of conservation of energy implies total energy is equal to constant. Do you agree? What is total energy? Total energy is equal to kinetic energy plus potential energy. Let's have, for kinetic energy, we will treat it as T and potential energy is U. Or we can keep kinetic energy as kinetic energy only. We took potential energy as U. Then what happens? TE is equal to constant. Implies d by dt of TA is equal to 0. The rate of change of total energy of a system is 0, because total energy is constant. The derivative of a constant is 0. What is total energy? That is nothing but d by dt of kinetic energy plus potential energy, that is equal to 0. That implies d by dt of kinetic energy plus d by dt of potential energy is equal to 0. That implies, what is the d by dt of kinetic energy? We have just derived x dot x double dot, x dot into x double dot plus d by dt of potential energy, it is also a function of x. Can we write it like this? d by dx of potential energy into dx by dt, because d by dt of anything is equal to dp by dx. Anything p, let us say dx by dt. This is from the basics of the differential equation, calculus. This is the gradient which I have explained in my vector classes, vector lectures. Please see them. Now, what happens? What is dx by dt? We have already defined. Dx by dt is nothing but x dot. Are you able to follow? That means x dot x double dot plus d by dx of u into x dot is equal to 0. Sorry, it is not x bar, it is x dot. That implies x double dot plus d by dx of u is equal to 0. That implies x double dot is equal to minus du by dx. When mass is introduced on both sides, this is the potential energy, du by dx. That implies that is what is the principle of conservation of energy. That means we can say work is equal to work done is equal to, instead of T, if you are convenient to call kinetic energy as K, then delta K, that is equal to K final minus K initial, that is equal to delta U means U initial minus U final. The rate of change of work done or work is equal to power, which we will be taking up in the next class. What is power? Now we have established conservation of energy principle, and also we have established the relation between kinetic energy and potential energy, and force is nothing but it is very important equation. Fx is equal to minus dv by dx or minus du by dx. Please remember this. The potential energy gradient is equal to force. The meaning of it is the negative gradient of potential energy is force. Because Fx is equal to minus du by dx, that is equal to minus dv by dx, according to the symbol you use for potential energy or kinetic energy. Now, as we have defined the potential energy, kinetic energy, now in the next class we have proved the what you call total energy also. In the next class we will be taking up a spring system, mass spring system, and analyze it. In the next class, mass spring system, and we will analyze it. With this I want to conclude this lecture. Thank you for listening to me. Thank you for viewing my lecture. And if you feel there is a value addition to you because of this lecture, kindly hype this lecture, share this lecture, and subscribe to my channel Maths and Science by IITian. Thank you for listening to me. Thank you for viewing my lecture. Best of luck to everybody.